This whole first page is just a whole bunch of information about rhombi and squares. So, a rhombus is a quadrilateral. Oh, that's too small. Yeah, I know. I just saw that. It's a quadrilateral with all four sides being congruent, and it is a special type of parallelogram. So it has all of the properties of our parallelogram as well. You don't need to, I just highlight everything because I do. So, that's a terrible picture. Let's try this again. That's better. Okay, so here's a parallelogram. All four sides are congruent, so then it makes it a rhombus. Okay. Things that we need to know about a rhombus. The first thing is the diagonals. They are perpendicular. Okay, so the diagonals are perpendicular. The next theorem just goes in the reverse. So if the diagonals are perpendicular, then we know we have a rhombus. And one other thing about this is that the diagonals bisect the pair of opposite angles. So what does it mean to bisect? Cuts it in half. So this diagonal here bisects it and bisects it. So those four angles would be congruent. And same over here. That bisects, 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 and bisects. Okay? No. Set it down. Set the book down. And focus on what we're doing. Focus. Okay. Square. A quadrilateral that is both a rhombus and a rectangle. Okay, so it has all the properties of both rhombi and rectangles. So what's a property that a rectangle has? 90-degree angles, and the new property of a rhombus? All sides are equal, so a square has all sides congruent and 90-degree angles. Okay, so this down here just highlights the different information about it. So a rhombi, it has all the properties of a parallelogram. So does a square. For a rhombi, all sides are congruent. A square also has all sides congruent. Diagonals are perpendicular, and the diagonal bisects the angles. So these three things about a rhombus, those also hold true about a square, because a square has all the same properties as a rhombus, in addition to all the properties of a rectangle. So it has all of those, plus having 90-degree angles and the diagonals being equal. Okay, so what we're going to do is we're going to have to keep in mind that these new properties, and we're going to do some solving. So here's our rhombus. So I want to find y. The measure of angle 1 is y squared minus 54. Why can we equal this to 90? Yeah, the diagonals here are perpendicular. Okay, that's one of the properties of a rhombus, is that the diagonals are perpendicular. So it tells us angle 1 has to be equal to 90. So y squared minus 54 is equal to 90. How would you solve this? I would probably add the 54. So 90 and 54 gives you 144. So take the square root. So what's your y? 12. Is that one okay? Okay, example 2. Find the measure of angle CBD, or CDB, if the measure of angle ABC is 64. So A, B, C, so this whole angle is 64 degrees. We want to find what CBD is? CDB is. So we want to find this angle over here. Thank you. Yeah, we just have to divide it by 2. Why can we just divide this by 2? Yeah, because it bisects the angle, so we can just take 64 and divide it by 2. So what does that give us? So 32 degrees. Okay, if AB is 2x plus 3 and BC is 5x, find x and AD. So this is 2x plus 3, this is 5x, and that's probably very difficult to read, so I'll go darker. So what can I do with those two? Why are they equal? All sides are equal. So 2x plus 3 equals 5x. Right, so subtract the 2x, you get 3 is 3x, so x is 1. We also want to find AD. How do we find AD? Yeah, AD is going to be the same as all of these other sides. So we just have to plug 1 back into one of those formulas. Okay, so 5 times 1 is 5, so that's the length of AD. Is that okay? All right. Number 4, find the measure of angle AEB and the measure of angle BCD if the measure of angle ABC is 83.2. So ABC is 83.2 degrees. We want to find AEB and BCD. Well, let's see here. Which one are we going for first? Let's do AEB first. So this angle, AEB. Yeah, that angle's 90. Why is that 90? They're perpendicular. Okay, so the measure of angle AEB is 90. Okay, BCD. BCD. So we want to find this whole angle. No, it wouldn't be 83.2. The angles aren't all congruent. But it does have all the properties of a parallelogram. So what does that tell you about your two consecutive angles here? They equal 180. So how would we find the other one? Yep, take 180 minus 83.2. 96.8. I don't know how you got that number. 96.8 degrees. Does that make sense? Is that okay? Okay, so now we're going to do some ones that involve graphing, where I'm going to give you points. 96.8 degrees was the answer for that. Okay, so I'm going to give you 4 points, and based off these 4 points, we want to say if it's a parallelogram, a rhombus, a square, or a rectangle. So in order to do this, we have to think about some of the properties. So before we start plotting or anything, we're just going to discuss some properties. We're going to focus on the diagonals. Okay. So let's see. We have a rhombus. We have a rectangle. And where would square fit in there? Is square both of them? Is a square a rhombus? Yeah. And is a square a rectangle? Yep, so square kind of goes, square comes from both. Okay? So a rhombus, what did we learn about the diagonals of a rhombus? They're perpendicular, okay? So we learned that the diagonals for a rhombus are perpendicular. How about for a rectangle? How are the diagonals related? They're congruent, right. So for a rectangle, the diagonals are congruent. For a square, they'd have to be perpendicular and congruent. Okay, so what we're going to do is we're just going to look at the diagonals. We already know it's a parallelogram, so we're just going to find the length of the diagonals and the slope of the diagonals. Based off of those two, we should be able to tell if it's a rhombus, a rectangle, or a square. If they're only perpendicular, it's a rhombus. If it's only congruent, it's a rectangle. If it's both, it's a square. Okay, so you can plot points if you want to. I think when you guys find slope, some of you like to count the slope. So that's perfectly fine. So we'll plot these points. So let's see, A is -2, -1. B is -1, 3. C is 3, 2. And D is 2, -2. Well, it might be. We'll have to decide. So what is, where are the diagonals first off? A what? AC is a diagonal, and what's the other one? BD is the diagonal. So that means we want to find the distance from A to C and the distance from B to D. And then we also want to find the slope of A to C and the slope of B to D. Okay, so let's find distance first. So our distance formula, change of x squared plus change of y squared. So from A to C. So A to C. So how much do your x's change from A to C? 5. So you have 5 squared plus, how much do your y's change? 3 squared. So 5 squared? 25. 3 squared? 9. So this is really the square root of? 4? 34? Right? Yeah? Okay. B to D. So from B to D, how much do your x's change? 3. 3 squared. How much do your y's change? 5 squared. So 9 plus 25, so we have square root of 34 again. Okay, so right now, what does this tell us? It's for sure a what type of shape? It's definitely a rectangle. It could still be a square, though, if the diagonals are perpendicular. So we're going to check that next. So the slope of AC, do you guys want to count, or do you want to do the slope formula? Count? Okay, so the slope from A to C, we have to rise 1, 2, 3, and we go over 1, 2, 3, 4, 5. Okay, from B to D, we have to rise 1, 2, 3, 4, 5. And we go over to the left, 1, 2, 3. So 5 over -3. So are those perpendicular slopes?
Yes.
Yeah, these are perpendicular slopes.
So it's a square.
So we have a square. Now I think some of you may have forgotten what perpendicular slopes look like because you were telling me no, these weren't. So how are perpendicular slopes related? They're flipped and they have the opposite sign. Okay? So page 434, 12 to 22, 26 to 31. Okay, so if you, so the way how you could have found out if it was a rectangle on yesterday's assignment was just check to see if the diagonals were congruent. That would have probably been the easiest way. But now you can tell the difference between all three.